Welcome to the Stormsurf video surf forecast for the week starting Sunday, May 19th. Looking at significant wave heights for the South Pacific Ocean, we see a gale starting to develop 31-foot seas just south of New Zealand. This is actually a little bit smaller than what was forecast earlier in the week, but this system is supposed to progress east across the South Pacific, generating, seas in about the same range for the next couple of days, resulting in some swell. So there is some hope. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough, just like this right here. Winds pushing, this is the southern hemisphere, to the north. That helps create a clockwise flow, which is aloft and also down at the surface, which is a sign of low pressure. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a trough right here. No big surprise because we know there's a gale here and we know it's generating seas. And this trough is being fed by 140 knot winds pushing up into it. So not bad. Let's see what it does. So we get into Monday. The trough loses a little energy but grows in aerial coverage. That continues into Monday night. Then the trough starts fading into Tuesday. Still pretty well carved out here. Should support some sort of low pressure gale development, maybe into Tuesday night. But then as we get into Wednesday, winds completely dissipate. And then this is kind of an interesting pattern. Yes, there's a bit of wind pushing under New Zealand. Still sort of a trough here, but just no energy associated with it. And if you look really closely, it almost looks like the jet is splitting, pushing down into Antarctica there. And then if that doesn't get it, it does it right there as well. So that sort of doesn't look particularly favorable, at least at that point, for support for storm or gale development. We're into Friday now. We're looking for some decent winds pushing to the north in the jet. And if anything, the southern branch, here's the southern branch of the jet, just looks very weak. If anything, all the energy's in the northern branch, and you get a sense maybe a ridge starting to build here under New Zealand on Sunday. And we'll just see where that goes. And here we are, 180 hours out. Yeah, kind of a trough, trying to organize in the central South Pacific, but not a lot of wind energy feeding into it. Just not looking particularly energetic at the moment. So, for now, it looks like the gale we have under New Zealand is probably it for the immediate future. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, no big surprise, area 40 knot winds, that's what's generating those 31-foot seas, just like southeast of New Zealand, if you will, embedded in a broader area, 35 knot winds. You need at least 40 knot winds, preferably 45, 50 or above, to build a long enough period swell. It's really the speed of the wind, the amount of time the wind is on the ocean surface, and the coverage of that wind, that's what generates swell, and it really determines its period. The more wind energy, the longer the period. And you need a long period to survive the, from here, 6,000 nautical mile journey up into California. Anyway, okay, so Sunday, we'll sort of put this in motion. We're into Sunday night. Fetch actually appears to be fading. Then we get into Monday. It kind of rebuilds, but just over a tiny little area here, 45 knots. Again, the key was aerial coverage of those winds, and most of it looks like 30 to 35 knot, not 40 or 45 knot. Anyway, we're into Monday night. Again, small areas, pockets of 40 knot winds. Yeah, that'll do something, but not super organized. There we go. Maybe Tuesday night into early Wednesday, 40 knot winds aim northeast, pretty good. And more of that as we get into the day Wednesday, and then things start fading out. We have a low here with 45 knot winds under New Zealand on Thursday midday, but it's falling south. Not of any interest. You need your fetch pushing to the northeast if you want to get swell into Hawaii, and or at least meaningful swell into Hawaii and California. Now we know we're into Saturday. The jet's kind of weak and falling apart. Surface synoptic charts basically indicating not a whole lot going on. See, there's a broad area. Now we get into Sunday. Remember that new trough starts developing in the upper atmosphere, and it manifests itself down at the surface, but only 30, 35 knot winds. A little pocket of 45 there, but not a whole lot. and there we are at 180 hours out. So kind of a lackadaisical pattern here, not a whole lot of energy supporting gale development. All right, let's go take a look at the wave models. So we're going back in time. We're into Saturday night a week ago. There was a gale that developed due south of California. California's like Northern California's at 122, Southern California about 117 west. So the cutoff window is right over in here. 32-foot seas, building quickly, strong winds, and this was as of Sunday morning a week ago, 43-foot seas, building to 49. Here's peak seas over this whole area, 49.2 feet right here on the hairy edge of the California swell window. There is swell in the water radiating north, even though most of this energy is pushing off, targeting, we'll say, Chile here and Peru. Swell will radiate north from there towards California. Very south angle, though, like 180, 182 degrees, maybe into Southern California, 180 to Northern California. And then it moved out of the California swell window. But solid long period swell certainly will result for Chile and Peru. The system faded out as we got into Monday. Another system developed here on Monday night, but it's pretty strong, but for the most part, falling south. See that? Here, we'll go back a little bit. Take a look. Watch it here. It's like at 55 south, we'll say. And then it's at 58 south. And then stronger with 44, I'll say 43-foot seas, but down at 60 south. And then even stronger still with 48 and 49-foot seas on last Tuesday night. But again, all this energy either falling south or aimed off to the east. Again, swell for Chile, Peru. For California, maybe not so much. We'll see. Verdict is still out on that. And then Wednesday, small system pushed under New Zealand, producing 30-foot seas. Unshadowed, but probably not big enough seas relative to California, but in the swell window for Hawaii, so they'll get some swell from that. And then things kind of went into a funk until we got to, well, you'll see right about there, Sunday. This is today, this morning, and whoops, and that was it. This was the beginning. This is the 31-foot seas, beginning of a new system. Let's go take a look at the forecast now. And remember, this system, we looked at the surface chart, we saw the winds, not particularly organized, so the expectation is, look, we're into Sunday night, still 31-foot seas. Hoping for something better, because 31-foot seas, especially shadowed behind Tahiti here, isn't going to produce a whole lot for California. Get a little area of 32, 4, 6, maybe 38-foot seas, something like that. Just not very impressive. The small coverage of those seas is not super conducive to solid swell, but at this point, we'll take anything, right? 32, 33-foot seas kind of thing, and that continued on into Wednesday. I mean, it is a good long run of small, we'll call it background plus sort of swell. Tahiti will do quite well, indeed, because they're far closer, but California, not so much. Peru, yes. Chile, some. Central America, yeah, pretty good. Anyway, all right, so we're into Thursday. Yeah, the system develops, but it's falling southeast of no interest, and it dissipates. And then we have that weak jet stream pattern, and then something is supposed to be developing in the central South Pacific. We're at 180 hours out. We saw winds were only 30, 35 knots. Seas, what's this, 20, 22, 24, 26-foot seas. That's not much. That's good for 14 or 15 second period swell. Probably won't even make it to California, if anything. Tahiti, for sure, though. All right, let's continue on. So we're looking at the northern hemisphere. Why would we be doing that in May? Because it has decided to wake up. The active phase of the MJO is still in control of the West Pacific, feeding the jet stream, and the correlation is much stronger with the active phase in the northern hemisphere than the southern hemisphere. So, sure enough, so just to be clear, there is swell from this system, which actually had like 23-foot seas a couple of days ago. That swell is hitting California now. 6, 7 feet at 13 seconds, kind of bumpy and weird from all the weather north of Point Conception. But there are waves. It's rideable. Anyway, new system develops. This is as of right about now, 25-foot seas forecast off of Oregon. And that continues building to 26-foot seas and 27-foot seas on Monday morning, targeting Oregon, Central and Northern California primarily. And that swell, you can just sort of watch the seas. It's going to be a raw swell indeed. You can see the system pull right up to the coast, 19-foot seas off of Northern California, sometime, we'll say, mid-Tuesday. So, yes, certainly swell will be in place, but the suspicion is also wind will be hitting at the same time. And you can see, you almost get the sense that this is all generated local wind swell. What is that? Probably 17-foot seas. So probably pretty much of a mess. We're into Wednesday and Thursday, and then things in the North Pacific pretty much die out for the season, and there's no realistic expectation that we'll get another swell-producing gale in the north after that. All right, so let's take a look at the wind situation, see what's going on, wind swell production or just surf conditions in general. High pressure northeast of Hawaii, 1024 millibar high. Yeah, generating some 15-knot winds, but not over a very large area. Kind of hard to build any noticeable wind swell there. California, low pressure right over the coast. It's been raining off and on all day in central and northern California. A little bit of snow in the mountains. North winds off the coast, 25 knots. The sea state is pretty jumbled in California, even at protected breaks. Even though there's swell hitting, it's kind of warbled, messed up. Anyway, so here's our new system forecast developing Sunday night with 40-knot winds. That continues. Also notice here as we get into Monday now, a decent-sized fetch area, 15-knot winds pushing to Hawaii, maybe some wind swell from that. California is going to certainly see more than just wind swell with 30-knot winds just blasting off the coast as we get into Monday night. Fetch continues for Hawaii as we get into Tuesday morning, actually looking much better, driven by high pressure, right? Clockwise winds around the high. Good area, 15-knot winds, wind swell for east-facing shores there. And here comes so we know swell's supposed to be hitting northern and central California on Tuesday, but you can see the wind machine just cranking up, low pressure inland, high pressure off the coast. That creates a gradient, tightens the isobars between the two, and you just get north winds out of that. And that is expected to blow pretty good as we get even Wednesday, 30-knot winds off the coast there. Fetch starting to pull away from Hawaii a bit. Maybe some wind swell on Wednesday with cleaner conditions. Winds nuking 35 knots off of Northern California on Wednesday night. And then, interesting, Thursday, finally, weak low pressure pushes off the coast just enough to create maybe a light south wind flow for central and portions of northern California, while the gradient continues over the north, large wind swell, and maybe decent conditions. Also, Hawaii, notice wind swell here, east winds at 15 to 20 knots, more wind swell for Hawaii for Thursday, and then Friday, high pressure still in control, more wind swell for Hawaii, and diminishing wind swell for California. We get into Saturday. Yes, wind swell, but that is even fading fast as the high starts weakening, losing, and the gradient starts fading off. And as we get into Sunday, basically a light wind pattern everywhere and wind swell dying out. And if there's any southern hemi swell left, that would be the best shot. A quick look at precipitation for California. Supposedly the models are showing snow up in the Sierra, not so much at Tahoe, and chain controls are down, but they got, 5 inches overnight, maybe another inch or 2 during the day. Off and on rain nonstop for the San Francisco area all day today. A good amount of rain accumulation up to 3 inches in the San Francisco Bay Area, not at the high spots, just in regular in-town kind of spots. So that's pretty unusual for this late in May to get that much precip from, this was over the past, 3 or 4 days. Anyway, you see precipitation dying out. One more system, Tuesday storm, winding up off the coast, comes in. Yes, more rain, not particularly heavy, but steady rain. A little bit of snow for the mountains. And then high pressure builds in quick as we get into Tuesday night. The snow pretty much fading out by Wednesday morning. And then it's a high pressure regime, supposedly little bit of snow showers maybe for the southern Sierra, but we'll see about that. And then that's probably it for precipitation. Now, interesting. The Sierra, backdoor, low pressure. See low pressure there? So the Sierras could be getting rain and even some snow as we get into late in the work week, Friday into early Saturday, while it's dry on the coast. And that continues for a little bit into Saturday and even into maybe Sunday. It's hard to say. That's a week out. Don't know that I believe any of that. But anyway, you get the general pattern here. High pressure is going to take over, and the expectation is that's probably it for rainfall, or meaningful rainfall for California for the season. Snow forecast dashboard for Squaw Valley. Supposedly accumulations from the, we'll call it the Tuesday, Wednesday event, maybe 10 inches or so. Now, this is the interesting thing here. So you can see the accumulations. You can see, so this is temperatures. Reds are non-freezing temperatures. Whites are freezing. Blues are more than freezing, 28 degrees, supposedly. So this is the bottom of Squaw. This is the top of Squaw. You see freezing temperatures basically to the base while we get all this snow right here. And then right after that, boom, things start warming up, and we're back into a very warm setup about a week out. But even a day after the snow stops, snow will be melting fast as temperatures start rising. Let's take a look at Mammoth, too. Far less snow for Mammoth, but also remember those couple of snow, we'll call them snow showers, forecast almost a week out. You can see the blue there, more accumulation. So maybe only 4 inches for Mammoth, but then it creeps up to maybe 9 or 10 inches a week out. Temperature profile, because they are higher, 8,000 foot base with a peak up at 11,000 feet. Yes, you could eke out some snow at the peaks up in the mountain or mid-mountain and up, but once you get to, what is that, the 22nd of May, Wednesday, you see above freezing temperatures down low and the same temperature profile. A warming pattern coming, signaling that winter is over. All right, so let's go take a look long term. What's going on with Madden-Julian Oscillation and El Nino? So first we focus on the MJO and the active phase of the MJO when it's south of where you are. Preferably what we want it over is in the western Pacific in what we call the Kelvin wave generation area, because that would help build another Kelvin wave, and Kelvin waves are what help form El Nino. All right, so East Pacific here, West Pacific here. This is data from the TAO buoy array, a series of buoys strung across the equator, used for monitoring El Nino, but they also have wind sensors on them. You see winds, this 5-day average winds from the east over most of the Pacific. Here's the date line right here, but once you get west of there, you can actually see it's not west anomalies, full-on west winds. That would be a sign of the active phase of the MJO. Anomalies, differences from normal for this time of year. So you see strong east winds. Well, is that stronger or weaker than what is normal for this time of year? You look at the arrows here. There pretty much aren't any, so you'd go, that's normal. But these little west winds here, that west winds turn into stronger west anomalies, meaning it's effective of a broader area of west winds filling the Kelvin wave generation area from 135 west to not the date line, but 170 west. 135 east to 170 west, 5 degrees north and south of the equator. When you see these westerly anomalies, that takes warm water that's normally here, pushes it east, it falls to depth. A bubble of warm water traverses the whole way across the Pacific over about a 3-month period, and then erupts somewhere either in the far East Pacific or in the Central Pacific and creates a pool of warm water on the ocean surface, and that is what starts El Nino. You get enough Kelvin waves, and they're strong enough and have enough duration, then you keep persistent warm water in this area. That changes the jet stream, that changes the upper circulation, and that really is what makes a true El Nino. So what's been going on the past month or so wind-wise? Okay, well, this is the whole planet on one chart. The date line's right up the middle here. The Kelvin wave generation area, or the far west Pacific, goes from about here to about here. And the whole Pacific on this chart goes from equatorial Pacific from here to over to about here, something like that. But it is this area between this point and this point going up. You see red. Westerly anomalies, westerly wind bursts, strong westerly anomalies in the West Pacific started, we'll say April 24th, can blew solid through the beginning of May. Look like they're just about ready to wrap up, maybe 2 more days, 3 more days of westerly winds, and then we sort of fall into a neutral pattern. It's also interesting to note here, so you can see that the westerly winds moving from west to east over time. That is the active phase of the MJO, moving from the West Pacific. But notice here by May 25th or so, westerly anomalies south of California. This is all on the equator. Still probably feeding some weather into California, but probably not a lot by that point in time. Most of the energy seems to be going to happen right around here. You see, it is pushing into California even there. So when the active phase of the MJO is south of any point on the planet, in this case south of California, then you can expect weather in California. Maybe not 100% guaranteed, but, and you also would expect tropical activity. Maybe some tropical activity in the equatorial Pacific. We'll see. Probably a reach. Too early in the season, but maybe. Anyway, so this westerly wind burst, here, we're interested in it because we think maybe it's going to create yet another Kelvin wave, and we definitely need it if we're going to have any hope for El Nino into next winter. So let's see what the MJO is going to do. This is outgoing long wave radiation, OLR. Another way of looking at the MJO, okay? The blue patch here. So we're interested only in the equatorial Pacific. You see red here in the Indian Ocean. Red means positive anomalies. That means a bunch of sunlight reflectivity off the ocean surface, clear skies, high pressure. That would be the inactive phase of the MJO. The blue would be the active phase of the MJO over the date line. And you can see this is the initial date, days 1 through 5. Yeah, MJO holding on the date line, and then getting very weak days 6 through 10 out to 15. And the inactive phase of the MJO moving from the Indian Ocean, little bit of time, you can just sort of draw a line through it here, moving into the West Pacific 2 weeks out. That point in time, the storm regime should probably shut down, certainly for the North Pacific, and probably be very weak for the Southern Hemisphere as well. And that was the statistic model up here. Now we're looking at the dynamic model. It's saying almost the exact same thing. We'll just go right to 15 days out here and 15 days out here. You look at them, they're almost exactly the same. The two models are in sync. So 2 weeks out, we're in the inactive phase of the MJO in the West Pacific. So one would not expect a whole lot of swell production, probably for about the 2 to 3 week window, maybe up to 4 weeks, as it'll take for the inactive phase to traverse the Pacific, going from west to east. Here's phase diagram charts, another way of looking at the MJO, where it is. So assume you're looking down on the North Pole, and the MJO moves around the equator from west to east, from the Indian Ocean to the Maritime Continent, through the West Pacific, across the Pacific, East Pacific, under the United States, across the Atlantic into North Africa, and then popping back out into the Indian Ocean. So the heavy dot right there is where the active phase of the MJO is. Here's where it's been. These dates, so this would be like May 6th, it was in the West Pacific. The further away it is from this part, the stronger it is. So this active phase, the MJO, has been pretty weak nonstop. This is all of May, the beginning part of May. And now, as of the 14th of May, this is actually the 19th there. Forecast, so this chart, anyway, you get the idea. Forecast, moving towards the Indian Ocean, pretty weak. That's per the statistic model. This is per the dynamic model. Same basic deal. Weak active phase of the MJO in the exact other side of the planet where it needs to be. So no, basically that means inactive phase in the West Pacific. Here's the 40-day upper level model. This is up like jet stream level, 200 millibar level, even above that. The greens are favorable for areas favorable for precipitation. There's South America, there's New Guinea, Australia, there's the equator there. So you see, this is our active phase moving out and pretty much gone by May 26. This is areas not favorable for precipitation. That would be the inactive phase, the MJO, and you can see it setting up on May 23rd and taking till, before it gets into Central America, June 12th. So about, 3 weeks to make its way across. And then you can see the active phase setting up in, June 7th or so, and then it pushing its way across. So if we'll say June 7th into the end of June, that would be a good window perhaps for storm development in the southern hemisphere, but the correlation between the MJO and the southern hemisphere storm pattern is not as tight as it is in the northern hemisphere, but still, that's our window. And then after that, a week inactive phase perhaps. And yet one more model. So, okay, same deal. All the planet on one chart, Kelvin wave generation area between 135, somewhere about from there to there, and California is down there. So, and we're going up. You see this, these are here we go, westerly wind anomalies at 850 millibars. That's up about 4,700 feet. Good proxy for what's going on down at the ocean surface. Here was our active phase, these solid contours, with a significant westerly wind burst going on from late April into, here's May 16th, today's date. And, well, actually, it's a couple days behind, right? Because we're at the 19th. Yes. So we're actually down in here somewhere. But you get the sense there was a good active phase with westerly anomalies, but it's fading, moving out of the Kelvin wave generation area. Here comes our inactive phase, and by the time we're into June 13th, the inactive phase in this model is taking control of the Kelvin wave generation area. And yet one more, the last one, MJO model. So this is past performance down on the bottom, the forecast at the top. Notice this. A big westerly wind burst on the dateline. This was back in February. That has produced a Kelvin wave. That Kelvin wave is erupting. It's almost done erupting now. So it was in February that the west winds created it. And February to March, April, May, that's 3 months. The warm waters created when these westerly winds started blowing in the West Pacific have arrived and are erupting and almost gone in the East Pacific now. Now here's our new Kelvin wave associated with, here we go, the active phase of the MJO. Not as strong looking as this one back in February. Anyway, you get the picture. MJO pushing east out and pretty much gone by, this will say May 27th, something like that. Inactive phase of the MJO through mid to late June, and then another big active phase with westerly anomalies. So this would be our next window for swell production. We'll say mid-June up until mid to late July. So basically, we're going to have some downtime from late May into early June while this inactive phase takes over. Oh, and low-pass filter. Yes. What's going on with El Nino? Okay, so this overlay shows, when you see these solid contours, that's a low-pressure bias over the dateline. That is effectively an indicator of El Nino, and you can see what's potentially going to happen with El Nino as we get deeper into the summer. We went from 3 contours back in the spring and February time frame. We're at 2 contours, 1, 2, but that is supposed to be fading out as we get into, maybe July 8th or 9th or so, and then we're down to 1 contour. This is not suggesting that a strengthening El Nino system is setting up. If anything, it's getting weaker, and we'll talk more about that in a minute. All right, enough talking of the MJO, westerly wind bursts, and Kelvin wave formation. What's actually happening, let's discuss what's actually happening in the ocean down at depth. So this is the West Pacific here. This is the East Pacific. This is down 100, 200, 300 meters. Again, these are the anchor lines on the TAO buoys on the equator. The X's are the sensors on those anchor lines. Okay, and from that data, with a little bit of fancy modeling, you can build a profile of what the subsurface temperature looks like. We have 30 degrees centigrade anomalies in the West Pacific. Here's the 29 degree isotherm line, holding steady at about 160. 28 degree isotherm line pushed the whole way into Ecuador a couple weeks ago with a peak arrival of the Kelvin wave there. It is slowly retracting at 142 west right now, so a little bit east of Hawaii. And then the 24 degree isotherm pushing still into Ecuador, suggesting we're nowhere near La Nina. If it was La Nina, this guy would be probably terminating up in here somewhere, but he's the whole way in to Ecuador, suggesting warm water still holding pretty close to the surface the whole way across the equatorial Pacific. Differences from normal for this time of year. All right, so here's 0. Everything above this is warmer than normal. 1 degree anomalies, but nothing. There's a little patch of 2. There's a little patch of 2 degree anomalies there. That was what was Kelvin wave number 3, but it's all bleeding to the surface anywhere from, what is that? We'll say 140 west into Ecuador, and probably most of it more out here and not so much there, which means this is sort of a westward displaced, upwelling Kelvin wave, which has been the same as Kelvin wave number 2 and Kelvin wave number 1, which means this whole El Nino-ish thing is more like a westward Modoki, westward displaced El Nino. There hadn't been the huge buildup of warm water along the coast of Ecuador, and we'll get into that in a minute. We'll see it in the surface charts. Anyway, so right now, it's a warm regime, but there's also this pocket of 2 degree anomalies, and we think that might actually be trying to poke up here. Some of this is the upwelling phase of the Kelvin wave cycle. We're hoping more warm water because westerly winds, remember, westerly wind burst is over here in the West Pacific, pushing warm water off the maritime continent, trying to build a bubble right here. So let's take a look here. Here is another version of that data. And you can see very clearly upwelling phase of the Kelvin wave cycle here. Cool water at about 105 west, somewhere south of Mexico, something like that. Here's the last bit of our El Nino-ish warm water. But we also noticed last week, this one here, building warm anomalies here in the far West Pacific, associated, we believe, with westerly winds, the west Kelvin wave, or westerly wind burst number 4, trying to create maybe Kelvin wave number 4. But we suspect that the warm water pool is pretty much tapped out over here, and even if we do get a 4th Kelvin wave, it's not going to be particularly strong. Sea level anomalies from the JSON 2, JSON 3 satellite. You strip out all the surf, strip out the wind waves, strip out the tides. We're looking for a positive bubble. See, there's a positive bubble there, but it needs to be on the equator, and that would mean a Kelvin wave. We see absolutely no sign of it there, only the weakest signs of it right here. So westerly winds, there's New Guinea. This is where the westerly wind anomalies were, the Kelvin wave generation area from. Would, in your mind, just draw a box right in there. And we've had westerly winds there, but this sense is that there isn't a whole lot of warm water here to start with, so you can have all the westerly winds you want, and it's not going to create a Kelvin wave because there's no warm water to push off to the east. And this chart is kind of confirming that. Upper ocean heat anomalies right here. All right, so this is the West Pacific here, East Pacific here, but we have time as well. And the reds are warm temperatures. So this was Kelvin wave number 1 here back in June last year. It erupts along, most of it peaked out here. So where is that? That's at 130 west, right? Okay. So we talked about this westward displaced El Nino thing, all that driven by Kelvin waves, which are driven by westerly winds. The Kelvin waves didn't have a lot of strength, didn't have a lot of warm water, a lot of momentum, so they only made it 2/3 of the way across the Pacific and erupted there. And you can see it, some made it east, but not enough. Upwelling phase of the Kelvin wave cycle. Kelvin wave number 2 did better. It made it to, what is that? 100 west. Okay, so maybe the little bit west of the Galapagos, and it all erupted, a little bit moving east. Upwelling phase of the Kelvin wave cycle. Kelvin wave number 3. This is the one that's been erupting in March and April, and it's pretty much all gone. It made it to 120 west, which is due south of California, and then it started fading. Didn't have the longevity or the momentum to keep moving east. Upwelling phase of the Kelvin wave cycle. And then we think there might be another Kelvin wave being generated, but you kind of look here, you go, wait a minute, look back up here when all the first Kelvin waves are going. There's a lot more warm water in the West Pacific. Now it all looks tapped out. So again, that issue. You can have all the west winds you want here, but if you don't have warm water here, you're not going to get a Kelvin wave. Part 2. Another way of looking at upper ocean heat anomalies, which this other chart was the same deal, but this is just graphically. And you see we had a lot of warm water traversing the West Pacific between 100 west and the dateline, so south of Mexico to the dateline. And here's where we are today. That doesn't look particularly favorable. So these are the upwelling phase of the cool spots in between the Kelvin waves, but we're way down here, not looking like there's going to be some massive Kelvin wave behind it. All right, sea surface temperature anomalies. All right, we talked subsurface, so what's going on at the surface? These Kelvin waves erupt, right? There should be a big pool of warm water somewhere, right? Well, we looked at the previous chart, and it kind of looks like all the Kelvin waves so far from this El Nino have erupted in the, we'll say, the 120 to 140 range, somewhere right around in here. And look at this. Here's warm water, but as you go east, yes, there's warm water, but less aerial coverage, much broader pool. Okay, this is kind of a zoomed-in view. But you get the sense all the warmth is off to the west. That, again, would be your westward displaced sort of El Nino, Modoki El Nino pattern indicated. Here, this is going out to the dateline. So we have warm water from New Guinea to, I'd say, somewhere around south of California, but not as much east of there. Let's go take a look at some other data. Here's the 7-day trend. Actually, about 3 days ago, things looked pretty bad. There was cool water off of Peru, and you could see it going from here, streaming along the equator. You know east trades are blowing here. So you got the sense of some upwelling event here and pushing east to 120. Then you had this persistent warming trend out over here in the central Pacific, moving to the West Pacific. But looking today, that cooling trend looks to have backed off some. You can actually see the remnants here where the green is, and the blues are cooler than normal waters. So this whole area right around in here kind of looks like it's been cooling lately. Only 7 days, so this is not, doesn't mean the water is cold, just means it's cooling compared to what it was 7 days ago. So here's the overall sea surface temperature anomaly trend chart. So the official El Nino monitoring region, 120 west to 170 west, 5 degrees north and south of the equator. You just eyeball this, you can see most of the warmth is, yes, in that region. Most of it starts at about 140, right around in there. As you get close to Peru, Peru, Colombia, Ecuador, there is warming. But if we were in a real El Nino, we've said this before, there'd be this big old triangle and all the main heat would be right here. And we're not seeing any of this. This is just sort of a generic warming trend. You also see all the temperatures across all the oceans are warmer than normal. We're not going to go into that debate tonight. But what happens is it's harder to discern an El Nino if you're in a situation where the planet's oceans are warming continuously, and that's where we are. Sea surface temperature index numbers. So this is the Nino 1.2 region area. This is the area right there along Peru, Chile, Peru, Ecuador, Colombia. Temperatures today, minus 0.84, dead neutral basically. And you can see the trend, this whole El Nino cycle. Yeah, we had peaks, but we had lows, and the average pretty much is right at zero. If you sort of eyeball it, there's a low, there's a peak, there's a low, there's a peak. the East Pacific never warmed particularly, and it just held basically average, average, neutral, normal for this time of year, which leads us again to that conclusion. This was a westward displaced El Nino event. You look at the Nino 3.4 region, which was started 120 west out to 170 west, and temperatures today are 0.372 above normal. But other than that, prior to this, they've been all half a degree or more, somewhere between half a degree, averaging probably about 0.7 or so of a degree above normal since February, and even before then. We get the sense that our El Nino is slowly fading out. There's no more it doesn't appear that there's any real Kelvin waves in the pipe. Let's go do one little thing here. This chart still shows, 2 shades, 1 degree above normal anomalies from the West Pacific, making it to 120 west. So maybe 3 months worth of warming holding in this bubble, and maybe a little bit more coming behind it. So 3 months from mid-May to June, July, August. By about August, maybe all this will tap out. The atmosphere, though, is responding. We'll talk about that in a minute. It's responding a little bit to the warm temperatures on the surface, but because they're only very modestly warm, we'll scroll. Where is that chart? There we go. Because they're only modestly warm, the atmospheric response is not that strong. And once the temperatures go back to neutral, down to zero, it'll still take 3 months for the atmosphere to respond in kind. So let's say, May to June, July. So let's say in August, temperatures go neutral, August to September, October. So it wouldn't be till November or December before the atmosphere would start losing any momentum it was getting by heat transfer into the upper atmosphere from the warm anomalies in the East Equatorial Pacific. So what's going on in the atmosphere? Is it responding to the warm temperatures on the equator? Well, the Southern Oscillation Index is a good way of tracking that. Difference in pressure between Darwin, Australia, and Tahiti. If pressure is lower in Tahiti, the index goes negative. If the pressure is higher in Tahiti than Darwin, it goes positive. That's a good way, one, of looking at short-term changes like the MJO, and also long-term changes like the development of El Nino, because El Nino is basically like a long-running active phase of the MJO. All right, so we see back in mid-May, we were in the active phase of the MJO, westerly wind burst occurring, all that kind of stuff. We went down to minus 22.5. Where are we today? Minus 1.05, and prior to that, we were positive in the 10 range or so. So that sort of suggests we were in the active phase of the MJO. It's dying. We know that from looking at all the charts. No big surprise. 30-day average SOI, it's fading too. We were down to minus 6.88. Now we're at minus 3.74. The 90-day average, if the El Nino is like a long-running active phase of the MJO, then the 90-day average should be deeply negative if we were in El Nino, like minus 12 to 15. Well, we did get down to minus 7.84, 87. Now we're down to minus 5.94. So the trend's going the wrong way for sure. Let's take a look at the average chart. So here's the 30-day average, but charted out. You can see, so where were we? This is our El Nino. We'll say April of 2018. You can see this is the active phase of the MJO, inactive phase, active. And you see the trend was down. But then we kind of stalled in the January time frame of this year. And yeah, the surf kind of died February, March kind of time frame. And here's where we are, minus 4 or 5, something like that. All this stuff in here should be below the line if we were in a real El Nino. We're not, and we expect the trend to start heading up. So finally, the sea surface temperature forecast for the Nino 3.4 area, the official El Nino monitoring region. So here we are, May. The model has finally kind of gotten in touch with reality. Temperatures 0.75 degrees. That's about what it was at some point in May. This model suggests temperatures going up a little bit as we get into June. Maybe. Kind of doubtful. And then hovering right around 3/4 of a degree into October, and then starting to slowly fade. But still, hanging out in February. That's what, almost 3/4 of a year from now, at a half a degree above normal. That's probably overstated. We're probably looking at 0.2 of a degree. So looking at this, even discounting it heavily and saying only half of that's probably true, still we're looking at above average sea surface temperatures in the El Nino 3.4 region as we go into fall and even into winter. That's better than La Nina. Though, see the blues here? These are some of the more recent members of the run, suggesting, well, maybe that's a little bit overstated. Not moving to La Nina, at least not yet, but my guess is as we get into February, March time frame, we're going to start moving into some sort of modest La Nina sort of time frame. So the point being, get what you can get now. Surf while you can, because we suspect long term we're probably going to go into another one of these La Nina slumps where not as many storms, not as strong, longer time between storms. So make hay while you can. So to put a bow on things, there's a very south-angled southern hemiswell moving into California, or moving towards California from the southeast Pacific for this week. On top of that, piles of wind swell for north of Point Conception, and another Gulf gale swell, if you can believe it, in May, moving into the coast, but probably pretty blown out and pretty ugly. And then a storm or a small gale working its way from New Zealand off to the central Pacific through this week, so that'll put swell about a week out from there, or so 10 days. And then after that, things get kind of quiet for a while. Long-term outlook, yeah, general warming in the Pacific, sort of some weak El Nino-ish pattern. And as we get into, later in the summer, pretty much basically expect a normal kind of year in terms of swell production. Maybe a little bit enhanced. I mean, it was a pretty good run we had, what was that, Monday, Tuesday, Wednesday, Thursday. If it hadn't been for north winds and just horrible conditions up here in California, it was good while it lasted. So probably some more of that over the coming months. So not a bad outlook, not great, but, take what you can get. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.